All right, so again, we have our quadratic formula written there, and then just the little note to ourselves, one side must be equal to 0. And that is so that we take the correct values of A, B, and C. And it does have to be in order. When we move stuff around, it still has to be ax squared plus bx plus c. So order does matter here. So when we look at problem number 1 here, 12x squared minus 8x equals -5. Our first step is we have to add 5 to both sides here. I need that one side to equal 0. So 12x squared minus 8x plus 5 equals 0. Once I have it in standard form with one side equal to 0, then I can identify my A, my B, and my C. So in this case, A is 12, B is -8, C is 5. So when I substitute it in, I have x equals, my b value is already negative. So -8 plus or minus the square root. I have to put that -8 in parentheses to square it. -4 times 12 times 5. And that is all going to get divided by 2 times 12. So that's why it's very important that we are in standard form so that we pull the correct values of A, B, and C to substitute into the equation so that we do our calculation correctly. Now we have that double negative there in front of the 8, which is going to end up going positive. So x equals 8 plus or minus. And if we work that out, the -8 squared minus 4 times 12 times 5. What number goes under my radical? Bless you. And you have to make sure you're putting parenthesis, -8 parenthesis squared minus 4 times 12 times 5. You should get a -176. And then that's going to be all over 24 because 2 times 12 is 24. So then we have to look at the square root of -176, which we know is the square root of -1 times the square root of 176. That square root of -1, we're going to replace it with I. And then we have to see, are there any perfect squares that go into 176? Again, we're looking at 4, 9, 16, 25, 36, 49, 64, and 81. Do any of those go in? And if they do, what is the largest of those that goes in? Yeah, I believe 4 goes in as well, but 16 is the larger. Again, we're looking for that largest factor that's a perfect square. So it's 16 times 11. So that is my perfect square. So this is I times the square root of 16 times the square root of 11, which leaves us with 4I radical 11 that I'm going to use as a simplified. So down here, x equals 8 plus or minus 4I radical 11 over 24. So when I separate that out into my two equations, that gives me x equals 8 plus 4i radical 11 over 24, and x equals 8 minus 4i radical 11 over 24. Now, I can't combine here because of that 4i and radical 11, but I can reduce. But if you reduce, it has to be able to be with all three terms. The 4, the 8, and the 24 are all divisible by 4. So 8 divided by 4 is 2, 4 divided by 4 is 1, 24 divided by 4 is 6. So this becomes x equals 2 plus I radical 11 over 6. Those same reductions can be made in the other one as well. So we get x equals 2 minus I radical 11 over 6. So there's my solution set. So again, if we get that negative under the radical sign, we have to deal with that. I'm gonna move this down a little so it's not right on top of the answer there. But I will tell you, every problem from this section is not going to have an I in it. This is where we have to be able to evaluate and look at the information that we are given. Sometimes it will be a negative under the radical. Sometimes it won't. We can't just assume that it's going to be an imaginary solution. All right, number 2. 7x squared minus 7 equals 7x. So we're going to subtract 7x from both sides. And again, this is where it's important we make sure and put that in standard form. So it becomes 7x squared minus 7x minus 7 equals 0. So in this case, A is 7, B is negative 7, C is negative 7. So we get x equals negative 7 plus or minus the square root, the quantity negative 7 squared minus 4 times 7 times negative 7, all divided by 2 times 7. Again, we have that double negative out in front here. So x equals 7 plus or minus the square root of something over 14. What number goes under that radical? 245. Make sure you're putting that negative 7 in parentheses. So there's no negative in there, so I'm not going to have an imaginary solution. So now I'm looking at, do I have any perfect squares in the factors of 245? So again, I'm looking at 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Are any of those numbers a factor of 245? 49 is 49 times 5 49 is that perfect square. So the square root of 245 is the square root of 49 times the square root of 5 to give us 7 radical 5. Which means that x equals 7 plus or minus 7 radical 5 over 14. So that gives me x equals 7 plus 7 radical 5 over 14. And x equals 7 minus 7 radical 5 over 14. Now again, I can't combine the 7 plus 7 radical 5, but I have 7, 7, and 14. So I can reduce all of these by 7. So the 7s go down to 1. The 14 goes down to 2, giving me x equals 1 plus radical 5 divided by 2. And then the same thing happens on the other side as well, giving me x equals 1 minus radical 5 over 2. So there is my solution set. That is showing me the 2 points where my function crosses the x-axis. My first problem, because it had I in it, was telling me it does not cross the x-axis. But this one does cross the x-axis. Number 3, 2x squared plus x equals 13. The first step is to subtract the 13 from both sides. So 2x squared plus x minus 13 equals 0. So A is 2, B, because there's nothing else in front of that x, B is going to be 1, C is going to be negative 13. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 13, all divided by 2 times 2. So x equals negative 1 plus or minus something under the radical divided by 4. What value goes under the radical? 105. Again, it's a positive 105, so it's not an imaginary solution. I do have to see if I can simplify 105. And if I go through all those perfect squares, if I look at 4, 9, 16, 25, 36, and 49, I find that none of those go into 105. 105 is 5 times 21. 21 is 7 times 3. Those are all prime numbers, which means we do not have anything we can simplify. So honestly, from that point there, we get x equals negative 1 plus the square root of 105 over 4, and x equals negative 1 minus the square root of 105 over 4. There's nothing to reduce there. We already have 2 1s and a 4. There's nothing else that I can do, so that actually becomes my solution set. negative 1 plus radical 105 over 4, negative 1 minus radical 105 over 4. So again, not every radical can be simplified. It just depends, can we take any perfect squares out? All right, number 4, 5x squared equals negative 10 minus 7x. So I need to move the negative 10 and the negative 7x. I'm going to do it at the same time. I'm going to add 10 and add 7x to both sides. But again, order matters. When I write this, it has to be 5x squared plus 7x plus 10 equals 0. When you rewrite it, it does have to be in standard form, ax squared plus bx plus c, because that's how we know we're getting our a, b, and c correctly. So our a is 5, b is 7, c is 10. So x equals negative 7 plus or minus the square root. 7 squared minus 4 times 5 times 10. All divided by 2 times 5. So x equals negative 7 plus or minus the square root of something divided by 10. What number goes under that radical sign? Negative 151. That negative tells me now I'm going to have an imaginary solution. The square root of negative 151 equals the square root of negative 1 times the square root of 151. So I know the square root of negative 1 is going to give me I. Are there any perfect squares that are factors of 151? So we're looking at 4, 9, 16, 25, 36, 49, 64. Do any of those divide evenly into 151? No, there are no perfect squares that are there. None of those work. So this would just be I radical 151. The I telling us it's an imaginary solution because we got that negative under the radical. So we get x equals negative 7 plus or minus I radical 151 over 10. So x equals negative 7 plus I radical 151 over 10. And x equals negative 7 minus I radical 151 over 10. And again, I can't combine anything else. And when I look to reduce, there's nothing that goes into both 7 and 10, and the other coefficient is 1. So there is nothing to reduce. So that is actually my solution set. Negative 7 plus I radical 151 over 10, comma, negative 7 minus I radical 151 over 10. All right, number 5, 3x squared minus 9x equals negative 8. Add that 8 to both sides. 3x squared minus 9x plus 8 equals 0. So A is 3, B is negative 9, C is 8. So x equals negative 9 plus or minus the square root, the quantity negative 9 squared minus 4 times 3 times 8, all divided by 2 times 3. We have that double negative out front, so that's going to end up being a positive 9. So x equals 9 plus or minus some number under the square root divided by 6. What number goes under our radical sign? Negative 15. So if we're looking at the square root of negative 15, it's the square root of negative 1 times the square root of 15 equals I. And honestly, I expect you to know that 15 doesn't have any perfect squares because it's 3 times 5. So you don't have to go through a big, we know that this is just I radical 15. So x equals 9 plus or minus I radical 15 divided by 6. So x equals 9 plus I radical 15 over 6. And x equals 9 minus I radical 15 over 6. Now, when we look at this, you think, oh, 9 and 6 both have 3 in common. And they do. But does the other term have 3 in common? Can I divide 3 into I? No. So just because I can reduce 2 of them, I have to be able to reduce all 3 of them. So honestly, this is the simplified answer. I cannot reduce the 9 and the 6 if I can't do anything to the other term. So my solution set here, 9 plus I radical 15 over 6 and 9 minus I radical 15 over 6. That is as simplified as I can get it. Now I'm going to pause for a moment while you complete number 6 and we will check our answers to see if we are correct. All right, so number 6, we have 11x squared plus 8x equals negative 11. Now, I will go back and we'll work through how we get the answer, but I want to start with what is the answer? What goes in my brackets? What is my solution set on this problem? What did we get? Yeah, so we get negative 4 plus I radical 105 over 11 and negative 4 minus I radical 105 over 11. That's where we should have ended. We need to make sure we did all the steps correctly to get to that point. The first step would have been adding the 11 to both sides so that we have one side equal to 0. So we should have started off with 11x squared plus 8x plus 11 equals 0. So A is 11, B is 8, C is 11. So x equals negative 8 plus or minus the square root of 8 squared minus 4 times 11 times 11, all divided by 2 times 11. So x equals -8 plus or minus the square root. When we multiply all of that out, we should have gotten -420 all divided by 22. So the square root of -420 is the square root of -1 times the square root of 420. So we know we're going to have an I in this answer because of that negative sign under the radical. And then I need to do a factor tree of 420, and I'm looking for those perfect squares. I have a long list on this one. I'm not going to write them all out. 420 is quite large here, but you should have found that this is 4 times 105. So 4 is my perfect square. So I times the square root of 4 times the square root of 105 gives us 2I radical 105. So x equals -8 plus or minus 2I radical 105 divided by 22. Now I know that doesn't look like our answer, which means obviously we had to do some simplifying. So we have x equals -8 plus 2I radical 105 over 22, and x equals -8 minus 2I radical 105 over 22. We have -8, 2, and 22. They are all divisible by 2, so the -8 becomes a -4, the 2 becomes a 1, the 22 becomes 11, giving me x equals -4 plus I radical 105 over 11. And then I can do those same reductions on the other side, -4, 1, and 11, giving me x equals -4 minus I radical 105 divided by 11, which then does become our solution set. So the work you're going to get for this in just a minute, some of them may be imaginary, some of them may not be. That's why we have to understand, we have to figure out that number under the radical. If it's a negative, I'm going to have an imaginary solution. If it's positive, I'm going to have a real solution.